Hey everyone, in this video we're going to do a brief review of kind of the basics of molarity. There will be a subsequent video on how to actually make solutions with a given molarity. So we're going to just kind of get into the basics of the calculation in this video and then kind of get into the nitty-gritty as well as solutions in the second video. So watch out for that video if you're stuck on the kind of the details of making solutions, but this one's just going to cover the basics of how to do molarity calculations. This is going to center around the molarity equation. Molarity is defined as the number of moles, that's an M, moles of solute, the thing that's present in smaller amounts in a solution, divided by the volume in liters of the entire solution, all right? So up until this point, we've dealt with a few solutions, but pretty rarely because we haven't had a way to do this quantitatively until we get to this point, all right? So if you think about something like what we refer to as salt water, there is salt dissolved in the water. So that means that well, I'm trying to erase this. I'm struggling with my pen here. If you think about salt water, that's salt dissolved in water. So the solute is the sodium chloride, the salt that's dissolved. The solvent is water, all right? So the thing in the greater amount, present in the greater amount is always the solute. The thing that's present in the, excuse me, I said that backwards. The thing in the greater amount is the solvent. The thing in the lesser amount is the solute. We normally think of dissolving solute in solvent. And then all together, that makes a solution, which is the combined mixture of the two. All right, so this is all about mixtures. Remember from way back when we did nature of matter, we talked about mixtures being different from compounds and that they can be present in any ratio. So you can have any amount of salt, within limits, dissolved in any amount of water. There's no set ratio. That's what makes it a mixture. So we have to have some way to quantify that because we're chemists and we like to put numbers on things and we like to know how things are going to react with each other in terms of amounts. And so that's kind of the goal of this part of this lesson. All right, so let's do a calculation that will help make some of that make sense. So we're asked here, what is the molarity of a solution containing 5.175 grams of sodium hydroxide with a volume of 125 milliliters? So this is we should think of this as like a total solution volume. This is like a total solution volume. So the solution volume, not water volume, but the solution, the sodium hydroxide and the water together have this 125 milliliter volume. All right, so we're going to use that molarity equation. I'm going to shorten it like this, which is how we normally write it when we're kind of in a hurry. And we just want to know what is the molarity, right? So the molarity is abbreviated with this uppercase M. It is not the number of moles, it is the molarity, it's the moles per liter. All right, so I know everything starts with an M, right? I know it's a lot to keep track of, but anytime we write this uppercase M, that's moles per liter, not just moles. All right, so we've got to get this 5.175 grams of sodium hydroxide into moles in order to plug it in, right? So we're going to go to the periodic table. We're going to add up the molar mass for sodium, which is 22.99, plus oxygen, which is 16.00, plus hydrogen, which is 1.01, and that gives us a nice even 40.00 grams of sodium hydroxide in 1 mole of sodium hydroxide. And that's all we need. We don't need to do any other steps, just get grams into moles. So 5.175 divided by 40.00 comes out to be 0.1293 moles of sodium hydroxide. All right. Notice, so that's the numerator, so we're good there. Notice this denominator is in liters. It's the volume of the solution in liters. We're given the volume up here in milliliters. So, and I'm not picky about how you do this. You can think of this as a conversion factor. So there's, remember, 1,000 milliliters in 1 liter. And that means we divide by 1,000 and get 0.12500 liters. You can also think of this as just, it's in milliliters, we're going to divide by 1,000. Take your decimal place and move it 1, 2, 3 times. The decimal ends up there. Whichever way you want to think about this, I am good with, as long as you do it in the right direction. People get confused and move this over in the wrong direction and end up with 125,000 liters, which is like a swimming pool, so that's not correct. All right, so anyway, this is our volume in liters, so now we're going to plug in. The molarity is going to be equal to 0.1293 moles sodium hydroxide in 0.12500 liters of liters of sodium hydroxide. So we're going to punch that one in our calculator. This is going to give us a molarity of 1.035, which is 4 significant digits, so we're good. Molar. All right. Remember to always include the unit here. You can call it moles per liter if you prefer, but uppercase M is the more standard way to note the unit. All right. So change your grams into moles. That goes into the molarity equation. Change your milliliters to liters. That goes into the molarity equation. Divide. There you go. All right. So this can get a little trickier because we don't always just want the molarity of a solution that we've already made. Sometimes we want to know how to make a solution, which again, we're going to go into in more detail in the next video, but let's go ahead and work the calculation here. How many grams of calcium chloride dihydrate do you need to make 500 mils of solution with a concentration of 0.2 molar? It should say of calcium chloride solution. Okay, so again, we're going to look at the molarity equation and ask ourselves, well, what do we have? We have the volume, which is in milliliters. I'm going to go ahead and move that decimal 1, 2, 3. So 0.500 liters is going to go here, right? But we need, and we know here the molarity, right? We don't know the moles. We're asked for grams, and that sometimes confuses folks, but just work with what you have, right? So you know that this is 0.200. Right, so let's find the moles and see where we can get to from there. So we've got 0.200 molar equals moles per 0.500 liters. Multiply both sides by 0.500. You can also think of this as cross multiplying. It's really up to you. All right, and so the moles is going to be equal to, that should be 0.1. I'm going to punch it in my calculator so I don't screw it up. Oh, good. It's 0.1. I hate making mistakes in these videos because then I don't really have a good way to go back and fix them. All right, so that's going to be 0.100 moles that we're going to need to dissolve. But we're asked for grams, right? But we know how to change grams into moles. So this is actually pretty easy. So we're going to take that 0.100 moles. I'm going to just erase this to start here. And now we need moles of calcium chloride dihydrate because that's what we have in our bottle in our lab. All right, that's how it normally comes, is as the dihydrate. Remember, this dot doesn't mean times, it just means there's also water in here, and there's 2 waters for every formula unit of calcium chloride. So when we do our molar mass here, we got to take the molar mass of calcium, the molar mass of chlorine, 35.45, and then add to that 2 times the molar mass of water, which I hope by now you remember is 18.02. So we're going to add those up, times 35.45 plus 2 times 18.02. That gives us 147.02 grams of calcium chloride dihydrate per 1 mole of calcium chloride dihydrate. All right, and oh, I've done this upside down. So this is why it's important to look at your units, right? Because see, I noticed that this mole was in the is here, so the moles should be in the denominator. So I have this upside down. So we are going to erase this, and we're going to grab this because I don't want to write it again. We're going to move that to the numerator, where it's going to go, and that's going to be per 1 mole. That's a times 1 mole of calcium chloride dihydrate. Okay, and because I was checking that moles cancel with moles, I caught that mistake. All right, so now that's gonna, when we plug that through, that's gonna be 14.7 grams of calcium chloride dihydrate. All right. So that's the number of grams of calcium chloride dihydrate we'd have to dissolve to get a 0.2 molar solution, and then we dissolve it in up to into 500 mils of solution. Again, we'll talk about how to do that tomorrow. It's a little different than it sounds. All right. So I'm going to give you a practice problem. So what's the mass of solid potassium hydroxide you need to make 50 milliliters of 0.9 molar KOH? All right, pause the video, grab a piece of paper, grab your calculator, do the calculation, hit pause, hit play when you're ready to see the answer. All right, so again, we're going to use the molarity equation. And we know that we need to move this 3 times. So that's a 0.050 liters. We got 0.90 molar equals, oops, I'm not getting things right here, equals the number of moles over the 0.05000 liters of solution. So you can cross multiply or however you want to think about this. It's up to you. The number of moles comes out to be 0.05 times 0.9. That's 0.045 moles of KOH, but we want the grams because we're asked for what mass, right? So we need to give that in grams. So 1 mole of KOH has a molar mass, and I've lost my periodic table. What have I done with it? Having trouble remembering potassium off the top of my head. I used to have all these memorized. I think I'm getting old. All right, potassium is 39.1 plus oxygen is 16.00 plus hydrogen is 1.01. So 56.11 grams of KOH. And now we're done, right? So all of these are just one step because they're just grams to moles or moles to grams. So that, and moles cancel, so we actually did that in the right order this time. So that's 2.5, because we've only got 2 significant digits in that one. So that's 2.5 grams of KOH that we're going to need to make this solution. All right. So everything here centers around the molarity equation. Molarity is moles per liter. And a lot of times all you're going to have to do is an extra 1 step, changing moles back to grams. All right. Hope this was helpful. Let me know if you have any questions about this.